Okay, hi everyone. This video will finish up as the plane geometry worksheet 1. So we were previously at example 4. So for this video, I'll finish up part 2 of example 4. And then I'll do practice question 1. Then after you go back and finish up assignment question 2 and 3 by yourself. Okay, so let's look back at example 4. We have proven part 1 to show this equation here using the similarity of triangles. So let's look at part 2. Part 2, we are supposed to prove this equation over here. So what to do is that I analyze what I have first. I have dB over AB. If I look at this diagram, it is this dB here over this entire AB length here. And I have EC over AC, which is EC over this entire AC here. So if you can tell, this is another use of what we have to use, which is using similarity triangles, the properties of similarity of triangles. So once I've identified that the length that I use can be represented in the form of ratio, since the ratio of sides in a similar triangles are the same, therefore I can form the equation. So for part 2, since I know that I've shown in part 1 that triangle ADE is similar to triangle ABC, therefore I can write here, since triangle ADE is similar to triangle ABC, using what I want to find in the question, because the question wants to find dB, but by similarity of triangles, I know that this dB here can only be obtained from AB if I want to use a similarity triangle, the properties of similar triangles. So therefore, I start by saying that AD over AB, so from this case over here, AD over AB over AB is equal to, from this triangle, AE over AC. That's the first thing I can write. AE over AC. Okay. Then we know that from this part over here, we know that this question wants us to get dB. And this dB is made out of AD and dB. So therefore, I can rewrite this. AD is simply the entire length AB minus away this bottom part here, dB. Okay. dB over AB. And similar to this part here, since this question wants us to find EC, and this EC is this bottom part over here, I can rewrite this EC to be AC minus away AE. AC minus away EC to get AE. Okay, so therefore, I can rewrite this to become AC minus EC over AC. Okay, and therefore from here, then now I can cross multiply to remove the fraction from this equation. Therefore, if I rewrite it, this will be cross multiplying upwards, so I cross multiply in this direction. This will be AB times AC minus away DB times AC. This whole thing is equal to AC times AB minus away EC times AB. Okay, then from here, I can therefore notice that if I observe, okay, I will notice that I have AB times AC here and AC times AB here. This thing will cancel out each other. I can subtract from both sides, subtract AB times AC from both sides. What I'm left with would be, okay, to make it more clear, I'll just subtract this one from both sides. So now I'm left with negative dB times AC equals to negative EC times AB, and then I can simply multiply by negative to both sides of the equation to remove it. This will become dB times AC over EC times AB. Okay, and then from observing what the question wants me to get, I want to have dB over AB. So therefore, I simply divide both sides by AB and both sides by AC. I will simply obtain dB over AB equals to EC over AC. And therefore, I've shown what the question wants us to find. Okay, and this is for example 4 part 2. Okay, you can pause the video if you need more time to copy this down. Okay, now we look at the practice question. The final part of this video is this practice question before we move on to the next part. Okay, so let me make this. Okay, so for this practice question is simply applying what we have learned so far. How do we make use of this the properties of similar triangles, or to show that I've similar triangles in order to solve a plane geometry question. So let's look at practice question 1. Okay, for this part over here, we are given this diagram and MN is parallel to BC, and they say that these two angles are the same. So for part 1, prove that triangle ABC is similar to triangle AMN. So if I want to highlight this out, triangle ABC is this big triangle over here, triangle ABC, okay, triangle AMN is this triangle here. Okay, so therefore, if you can observe, this is a very straightforward similarity proving question. We know that there's a common angle here, and because these two lines are given to be parallel, we can observe that these are corresponding angles. So therefore, I can use the AA similarity test. So I start by identifying this angle here first. Okay, I know that, and I start with a small triangle first. Angle MAN is equal to angle BAC. Remember, the vertices must match, so it's just start with MAN. The big triangle should be BAC. Okay. And this is the common angle. And this is the first part of the similarity test, the A. The second one, we know that these two angles are the same by corresponding angles. So we will state that angle AMN in a small triangle is equal to angle ABC. This is because of corresponding angles, and we must state which lines are parallel. So this is MN parallel to BC. Okay, and this is the second A. So therefore, I can conclude that triangle ABC is similar to triangle AMN, and this is by the AA similarity test. Okay, and this is for part 1. Okay, now moving into part 2, I'm required to show this this equation here. So usually if we want to show this equation, right, we have to usually make use of what properties that we have shown in the question. So if I observe, right, I want to show that NC times AC is equal to AN times BC. I observe these sides in this diagram. NC is this side over here. NC is this side over here. AC is this entire long side here. And then I have AN times BC. And I have this side over here. So by similarity of triangles, I can conclude that if I want to write a ratio of these sides against these two sides here, I can form this fraction that the small triangle first, AN over AC is equal to MN over BC. Okay, then now I can cross multiply them. So if I cross multiply them, I'll get AN times BC equals to MN times AC. Then now I compare with what the question wants us to find. AN times BC, I have this over here. MN times AC. The only difference now is that instead of MN, I have a NC here. So I need to find some way to show that MN is equal to NC. So let's observe the question again. The question gives us an additional information that angle NMC, this triangle here, this angle, is the same as angle NCM, which means this angle here. So if you remember, in a triangle, if two angles are the same, this makes it an isosceles triangle. So therefore, we can conclude that from here, since angle NMC is equal to angle NCM, I can conclude that triangle MNC is an isosceles triangle. Okay, and what is the special property of an isosceles triangle? I know that MN is equal to NC. This is the property of an isosceles triangle, so therefore I can conclude that MN is equal to NC. Therefore, substituting back into the original equation over here from this equation, hence, I can obtain that AN times BC is equal to, instead of MN, you become NC times AC. And I have proven what the question wants us to find. Okay, please remember to write proven to tell the marker that you are done at this part here and we have shown what the question wants you to find. Okay, so this is the very simple part of how to solve practice question 1 in your worksheet. Please go back and finish up assignment question 2 and 3. Then I'll collect this back from you once you are done with assignment question 2 and 3. So that is all for chapter 9 worksheet.